In 5.5, our objective is to be able to order side lengths of a triangle given angle measures and order angle measures given side lengths. Also, we want to be able to determine whether a triangle can be formed given 3 segment lengths and determine the range for a possible third side length given 2 side lengths. Let's take a look at this picture. Here we have a triangle where I've shown you all 3 angle measures and all 3 side lengths. I'd like you to focus right now on the smallest of each of these. Here's the smallest of the angles. Angle B is only 36 degrees. See, compared to the other two, 36 degrees is the smallest. And the smallest side length of these 3 side lengths is 14.8. Notice that the angle and the side length that are the smallest are across from each other. If I make that angle even smaller, that side gets smaller because that side is connecting the rays from the angle here. So notice this angle that's made by ray BA and ray BC, this 24-degree angle, is how we create this side right here. The wider the opening, the longer this side will get. The shorter the opening, the shorter this side will get. Therefore, we will say across from the smallest angle, notice how this angle looks the smallest, across from it is the shortest side. Let's write that down. Across from the smallest angle, in this case in our picture, that's angle A, is the shortest side. Across from the smallest angle is the shortest side. Across from the smallest angle is the shortest side because those 2 sides of the angle closing together are going to create a smaller side. Similarly, let's take a look at the larger side. I'm going to show in this picture the largest angle of the 3 and see how across from it I'm highlighting the longest side, 20.9. And no matter, I can make that side shorter, but now I've changed which one is the longest one. Here's the longest side right here, and it's across from the largest angle. I'm going to make this angle really big again, and notice how now this side is highlighted across from it. So back in our picture, we can show how here's the largest angle, angle B. See this nice big obtuse angle right here, and across from it is the longest side, this side that says Z on it. So similarly, across from the largest angle in our picture here, that's angle B, is the longest side. In our picture, that's side Z or side AC if we use that segment connecting those 2 points. Up here we didn't write what the shortest side was. The shortest side, BC, that segment BC. So notice the largest angle across from the longest side, the smallest angle across from the shortest side. So that's useful because sometimes we're given limited information and we need to know more. For example, order the angles from smallest to largest, but I don't see angle measures in this picture. All I see are side lengths. So I can use these side lengths to help me determine the smallest and the largest of the angles. So looking at the side lengths, this is the smallest side. So I look across from this side, the angle that's not touching, not angle U and not angle F, those angles are adjacent to this side, but rather this angle will be the smallest angle. So angle N will be listed first. Going in order, the next smallest is this one that says 13. This one is in the middle, so across from it is going to be this angle that is in the middle. So next, angle F, and then the only one left, the largest of the 3 numbers, is 14. Therefore, across from it will be angle U. And now we've ordered from smallest to largest the angles without knowing their measure. We can do just the opposite of that. Order the sides from longest to shortest. Could you pause the video, try this on your own, and come back and see how you do? So which of these is the longest? Well, longest is going to be for my biggest number, so I want the big number to come first. Of all three, the biggest is this one right here. So looking across that angle is going to be that side right here. The two letters M and T connect to make that side, so MT will be the side that comes first. Now if I'm going down to the smallest, the shortest is the one that's small. So the shortest is here. I'm not ready for that one yet. So I'm going to go to the next in line, which is angle T. So across from angle T is this side that connects the M and the A. And then finally, the smallest one that I haven't done yet, angle M. And across from angle M is side AT. So how'd you do with that one? Let's talk about the relationship between sides of a triangle. Meaning, how can I create a triangle? I can't just use any three lengths and expect to be able to put them together to make a triangle. Take a look at this picture, for example. I put three segments together. Now, just because I have three segments doesn't mean they're going to connect. I'm going to try to drag this point and this point so that they join. And I'll bring them closer and closer together and closer, but it looks like I can't get them together. So just because I have three segments doesn't mean they will join to make a triangle. What do the lengths of these three segments have to be in relationship to each other? Well, this guy is too short. I could make this one longer, but how long does it have to be? That's the question. How long do these three segments have to be so that we're guaranteed that they're going to join? Well, notice that if I lay this one all the way flat down here, it's not going to quite connect. But if it does connect when it's flat here, that means these two little short segments put together are going to equal the whole thing if I could join them. But I need them to be longer such that they can actually have space in the interior here. So I can't have them exactly the same length as that bottom segment. I have to have them at least a little bit longer so that they'll connect. So take a look at this picture. So I'm going to show you first, this side AB is going to be stuck here at 30. And I'm going to move these. And I want you to see that if I get them really close to 30, where notice I'm adding them together. I'm adding them because I'm putting the segments together. This segment and this segment, I'm putting them together. So putting them together is adding them. Remember the segment addition postulate? Similar. So when I add them, see how it's 31.5. How is that related to 30? If I make them longer and I add them, see how it's 47.3. How is that related to 30? I'm going to make them as short as I possibly can in my picture here. See, when I add them, 30.2. How is that related to 30? No matter how I put these two sides together, notice how this number is always related to this third side. Did you figure it out yet? Well, I'm going to add these two sides. How is this related to 30? It's bigger. I'm going to add these two sides. How is this related to 30? It's bigger. No matter how I move these around or add these two sides together, they'll always give me a number that's bigger than 30. And that's the idea behind the triangle inequality theorem, is that two of the sides must add up to be bigger than the third side. In fact, here's the entire theorem that we can write down to help us. Given two sides of a triangle. So in this picture, let's say we're given side AB, this side right here, and side BC, this side right here, given these two sides. If I add these two sides, it has to be bigger than the third side. Well, another helpful hint is subtracting the 2 gives me what the third side has to be bigger than. Here's a more useful way to think of it. The third side, a side that we may or may not know, the third side has to be between, so less than, the sum of the other 2 sides. In this case, AB plus BC, and greater than the difference of the other 2 sides. In this case, AB minus BC. So that third side that we're talking about in this picture is this side that looks like the longest side in this picture. So we're calling that third side AC. That has to be between when we add the 2 sides and when we subtract the 2 sides. Let's see how we can use this triangle inequality. So just to focus on these examples, can the following lengths make a triangle? So I'm going to pick 2 sides, any 2 of these 3, and I'm going to add them and subtract them. 10 plus 6 is 16. 10 minus 6 is 4. Now I picked the 2 smallest just because it'll be easier arithmetic. So I'm going to ask myself, is this third side between these 2 numbers? That has to be the third side bigger than when I subtract and smaller than when I add. So 15, is it smaller than 16 but bigger than 4? Basically, when I put them between, does it look like it goes from smallest to biggest? And it does. So yes, these 3 lengths can make a triangle. Now, if you think about it logically, subtracting will always be smaller. So if you're picking the 2 smallest numbers, therefore, you really don't have to subtract if you're given 3 lengths. If you add them up and you get a number that's bigger than your third side, you know that those 2 sides are going to prop up to give you space because it's bigger than that third side. So that's really all that you need to do. So again, take these 2 lengths. 6 plus 10 is 16. Is it bigger than this third side? Meaning if this side is 17, this side and this side, will they be longer than 17? But no, put 10 and 6 together, they're not going to be longer. 16 is too small, not longer than 17, so no. Similarly over here, if I take these, add them up, I get 16. Is it longer than this third side? It's not, it's equal to it, which means putting these 2 sides together, the 10 and the 6 are going to exactly make 16. So they're going to fall down right on top of it. So this one, no again. Remember, when I add them, it has to be bigger than that third side. And 16 is bigger than 15. The reason that we like to do this subtracting and adding is because sometimes we need to know the possible lengths for that third side. So I gave you those 2 starting numbers again, 6 and 10. What could the possible lengths for that third side of the triangle be given these 2 lengths? So adding them and subtracting them gives me the range of those sides. So I can say the third side, or what I'm calling x in this picture, must be larger than 4, but smaller than 16. So for example, 4.1 is a possible answer. 5, 15.9, 12. So many possible answers between 4 and 16. We're not going to list them because there's too many to list. We're going to describe it as the range of possibilities between 4 and 16, which is another way to say it a little bit simpler. Between 4 and 16. Can't be 4 and it can't be 16. It can be between those lengths. Can you use this inequality theorem to describe a restriction on the possible values of x for this picture? Well, if we go back to the one right before this, it's very similar. Notice that I have these two lengths and x is the third side. What's another way to show between 4 and 16 using an inequality statement? Like this, 4 is less than x is less than 16. That's another way to write it. 3 different ways to write the answers to this one problem. Well, in this picture, given these two lengths, if I add and subtract, I get 16 and 4. So the third side must be between 16 and 4. Well, how do we write that with an inequality? 4 is less than the third side, which is less than 16. But then we just have to solve this inequality. Treat it like a three-sided equation. First, we have to minus 4 and write down what we have left. 0 is less than 2x is less than 12. Then we have to divide by 2. Do it to all three sides. And we're left with 0 is less than x is less than 6. So what could x be? Anything between 0 and 6. I could leave it as this inequality or say x can be any number between 0 and 6. Let's look at this example. You're standing 200 feet from a tall building. Here's you, tiny little you, tall building. The angle of elevation from your feet to the top of the building is 51 degrees, as shown in the figure. So think about looking up towards the top of the building. The angle made by looking up is 51 degrees. What can you say about the height of the building? Well, at this time, we don't know enough information to actually find the height of the building. But notice how this forms a triangle, the building, how far away you're standing, and the line of sight looking up towards the top. Using our triangle sum theorem, we know that all three angles have to add up to 180, so how much does this missing angle have to be? Well, we already have a 90, so 90 minus 51, 39. This angle has to be 39 degrees. So of the angles in this triangle, notice how this 51 degrees is bigger than this 39 degrees. So this one right here, of the two acute angles, obviously we know 90 is the biggest, but of the two acute angles, we know that this angle is the larger of the acute angles, the larger acute angle. Well, if this angle is larger than that one, and across from that angle is 200, what does that mean about the height of this building? Well, across from the larger angle has to be the larger side. So this building must be bigger than 200 feet. So what can we say about the height of the building? It must be more than 200 feet. See the usefulness of triangle inequalities? Can you think of other examples of situations outside of the classroom where knowing how to compare the sides or angles could be useful? Think about it and write something down. Now take a moment to summarize. Use your own words to describe how to determine the possible third side of a triangle given two segment lengths. See you in class.